Assalamu alaikum. Hello guys. So today we are going to talk about Border Gateway Protocol BGP, which is the most scalable protocol among all of the routing protocols. And first we assign IP address for each interface. We have one interface loopback in router 1 and we have two interface loopbacks also in router 5. So let's configure only the IP addresses. Configure terminal. The network is as you see 10.1140.1240.2140.2240, similar for all of the interfaces. So interface Ethernet 00, okay, 192 IP address 192.182.1.1, okay, the MASIC obvious 24 and no shit. That's for the first interface. For the second interface, IP address 192.182.1 MASIC, no shit. And the last, which is the interface loopback 0, okay, IP address 111 and the mask which is 32. We don't need to use no shut below the interface loopback. Why? Because it's virtual and it's always up. It's not the physical interface. Okay. Same for all routers. Enable connectivity. Assign the IP addresses. Okay, IP address which is 12 MASIC, no shut. Same for another interface. IP address 31, no shut. Okay, and router 3, enable connectivity interface Ethernet 0022. Okay, we just assign IP addresses for now. We didn't talk about BGP yet. Interface E01, the IP address 41 for this interface. No shut. And let's go for router 4. Enable connectivity interface Ethernet 00, which is 32. Okay, we assign 3140 and 3240. It's so obvious. If you already completed CCNA and going for CCNP, you should know how to assign IP address. Okay, exit another interface should be 51. Okay, the MASIC 24 for all of them except the interface back. And we are going for the last router. Okay, enable connectivity interface Ethernet 00 should be 42. IP address 192.162.42. MASIC 24. No shit. Again, interface Ethernet 01. IP address should be 52. Okay, so we assign IP address. And the last thing, we have to interface loopbacks in router 5. We should configure interface loopback 0, IP address, quad 4, and the mask is 32. Another interface loopback 0, loopback 1, sorry. We should change the loopback 0 for that one. IP address and the mask similar. Okay, now we assigned IP address for all of the interfaces. So we should start for the configurations of BGP. Like every routing protocols, just similar commands like router BGP, and then after that the autonomous system. What does it mean is by autonomous system? It means the network. We assign for router 1 autonomous system 1, for router 2 2, for router 3 3, for router 4 4, for router 5 5. Okay? So first of all, we have router, BGP, and then autonomous system. Okay, we can use this range from 1 to this range. Okay, we use 1 for router 1. Okay, and then after that, we have we can say no BGP default. Okay, IPv4 unicast. We can use it. No BGP. Okay, no BGP default IP version 4. We can use it, and we can use it. So it's not mandatory to use it. We can use it, and that's only for the recommendation to use it. So then after that, we have two things in BGP. We have neighbors, okay? We have to assign the IP address of the neighbors, also the autonomous system of each neighbors. For example, we have neighbor, okay? For this router, we have two neighbors, router 2 and router 3, and their IP addresses. The IP address of router 2 and the router 3 is the neighbor for router 1. Okay, so this IP address, for example, 1, 2, and then after that, remote AS. Remote AS. Remote AS, the autonomous system. What is the remote AS of that neighbor IP address? It's 2. Because we already said that we use autonomous system 1 for router 1, 2 for this, 3, and 4 and 5. Okay, and another neighbor, which is router 3, write the IP address 22, and the remote AS for this router is 3. Okay, and then after that we have another command, which is address family what IP version 4, because we use IP version 4 for this network, so we have to select it, which is IP version 4 or IP version 6. Okay, then after that we can use question mark for each of that IP version 4 unicast. Okay, that's it. And then we have one more thing. Yeah, we wrote already the IP addresses and the remotes. But if we did not activate the routers, which is the neighbor of the router one, then we don't have any neighborships. So similar command is just write the same IP addresses between two routers, okay? And then only activate. Just activate. That's easy. Maybe it's not that obvious for you, but in router 2 and router 3, when we configure all of that, you will not have any problems, inshallah. Neighbor for this router, 2 and activate. We have one more thing, guys. We have the interface loopback, and we have to inject it inside router 1. Okay? So there are three ways to do that, but we use the easiest one. What is the easiest one? It's the writing network and mask of that interface loopback to inject it to be injected inside the BGP routing table. So we use network what? This one. Okay, and mask, what is the mask? So it's 32. We have to write the similar IP addresses. So because the mask is 32 already, it's not 24 to write the last octet to be 0. So it does not need that. And the mask is 23 as well. So that's how we inject it. So router 1 is done. Let's move to another router. Router BGP 2, be careful because autonomous system for router 2 is 2. Okay. And then no BGP default IP version 4. We can use it as well. And it's not mandatory as I said. Then write the IP addresses, neighbor IP addresses, and the remote AS. So two neighbors, router 1 and router 4 for router 2. 1 1, the IP address of router 1 is 1 1, remote AS U1, and then the router 4 is 32, the remote AS, the IP address, and the remote AS, which is 4 for router 4. Then address family IP version 4, as we said, because we use IP version 4 for the entire network. then unicast, okay? And then we have to activate both IP addresses, which is 11 activate and neighbor 32 activate, okay? As you see, after the activate, it says that adj ADJ change. Okay, so you have neighborship is after the activation. Okay, we will have similar for the router 4 where we configured the router for Azure. Okay, because we didn't configure it yet, so that's why it doesn't say anything for the router 4. But for router 1, yeah, because we already configured it and we have neighborships. Let's move on for router 3. Similar exit. Okay, router BGP 3, autonomous system 3, as we said for router 3. Then after that, no BGP, no BGP default IP version 4, okay. And then neighbor, we have two neighbor, router 1, router 5, neighbor 21, okay, the IP address, remote AS1, neighbor, the IP address was 42, remote AS 5, because it's router 5, then address family, IP version 4, unicast, okay. Then we have, then we have to activate both IP addresses. 21 activate and then 42, which very easy. Let's move on for router 4. Router BGP 4. Okay, be careful about the autonomous systems. Two neighbor, router 2 and router 5. Okay, no BGP default IP version 4. Okay, we have neighbor 31 remote AS 2, neighbor 52 remote AS 5, okay. Then address family IP version 4 unicast, okay, which is pretty easy. And then we have to activate both of the IP address. 31 activate, then 52 activate. And we have the last router, router BGP 5, okay, two neighbor, router 3 and router 4, no BGP default IP version 4, okay, and then neighbor first router 3, which is 41, the IP address, remote AS3, and then the router 4, which is 51, the IP address. Okay, then address family, IP version 4, unicast, okay. Then after that, neighbor, both of the IP addresses, 41, activate. Then after that, 51, activate. Then after that, we have to check the connectivity. As you say, it will come as well after a couple of time, okay, both neighborship. So we have to check the neighborship. Show BGP IP version 4. That's how we verificate BGP, okay. Summary. So as you see, the timing is correct. So we have neighborship. It means our configurations is correct. It's similar for the routers. Show BGP IP version 4 unicast summary. Okay, we have the timing, so it's correct, and then similar for it. Even without it, you see the logs, this is log messages, so it's correct, but we have to verify it every time. It's correct, similar, it's correct, and the last router show BGP version 4 unicast summary. It's correct. And what we want to talk about right now. So, as you see, we have two passes to reach that network. From router 1, we have two passes to reach that two networks. As you see, let's verify. We just delete that summary and it's 1 1. Okay? And if we come to router 5, let's find out. Okay? We have two paths for this. And let's not forget that. We we did not configure the two interface loopbacks. Okay, we did not inject the two interface loopbacks for router 5. Let's configure it. So that's why it doesn't show in the routing table. Okay, okay. Now network mask, you have to inject it. So that's why it doesn't show. And then okay, now it's obvious. We have to wait a couple of minutes, a couple of seconds, sorry. Then it will show. Yes, you have to wait. You have to wait. It will show in both paths. You have to wait. We have to wait. You have to wait a couple of seconds. Okay, now we see. So we want to configure that. As you see, we have two paths to reach that to interface loopbacks. One path from this router and another path from this router. So let's check that. Let's check the path. 1, 2. If the traffic went from router 1 to router 2, then we have three hops, two hops, I mean, to reach that router 5. One hop, two hop, and that's the last one. So as you see, if you check the AS passes, what is AS pass? It means the autonomous system is that we use it for routers. If you select this pass to reach this network 5, then the traffic will go to router 2, which is AS2, and then router 5, which is AS4, and then AS5. Okay. But if you select this path, which is 2, 1, okay, which is 2, 2, sorry, the router 3, you have two AS paths. One router 3 and another is router 5. So if you verify that, it will tell you that from there it's the best path. Why? Because it's one router, one hop away, but from there it's two routers. How we can verify that? We can say show BGP IP version 4 unicast. We write the network and the mask. Okay. Then after that you see that two passes. First pass 1, 2 there, and the second pass 2, 2 there, and it says best. Okay. It says the best this pass. Okay. So why we say BGP is the most scalable protocol to select the best path? Because it has a lot of rules to describe that the BGP protocol has the best path selections. Okay. So we want, so as you see, there are some features for that. First feature, which is described by wait. If you configure wait in any of these passes, it will automatically select this pass as the best one. For example, configure one, wait for this, and it will select that pass as the best. Then the second one will be the local preferences. If you select if you configure local preferences for any of the passes, automatically then it will select that pass as the best one. So let's try one thing, guys. It says already that this pass is the best there. Okay, we want to change that. We want that pass will select it as the best. How we do that? For example, we do it in two ways. Okay, first way is not the correct way to configure, but I want to show you both of the ways to see how it's done. So let's see. For example, we say router BGP, okay, one, and then we want to select that, okay. So we just say no BGP default, okay, and we say neighbor. We want to select that path as the best and configure wait for it. How we do that? We say neighbor, okay, write the IP address of the neighbor 12, and then after that wait. Sorry, we have to write address family IP version for unicast, and then after that we have to configure it. So we configure neighbor and then the IP address of the remote router, okay, 12, and then after that wait. Okay, we select wait for it. For example, 10. Okay, if we check show BGP IP version for unicast, if we check the BGP routing table, it doesn't change. It's similar. Why? Because BGP protocol doesn't do any action by default. We have to provide the action. We have to provide the action to the BGP and then it does the changes. Because it's not like the other routing protocols to do the changes by default. How we do that? We have to do a clearing for BGP. For some features, for some attributes, like, for example, wait, local preferences, we have inbound. So we have two things, inbound and outbound. For some features like local preferences and wait, we have inbound. You have to do the changes inside the router. But for another feature is like, as we said, for the pulse selection, we have like more than 12 rules. For like IGP and committees, we have outbound. But now we use wait, so we have to advertise it from the inbound direction. So we do the clearing for BGP to select the changes. Clear BGP IP version for unicast. Okay. And then select the neighbor that we wanted to be changed, which is 12. Okay. And then after that, what? Inbound. We did that. Okay. Now check the routing. It's 1010. But it is not the correct way to do. Why? Because, for example, we just want only the network of 5555 to be selected the weight as 10, not the 66666 as well. So it selected both. Why? Because we didn't select any of that in any access bit or something. We just wanted that path to be the best to reach this network. If you check the routing table, for example, if we verify it, show BGP IP version for unicast, select any network, okay, any network. See, if you see that before before the change, it selected that route, that neighbor as the base path, which was 22 as the base. But now it selected that one as the base. Why? Because it has weight 10. Okay. So we want to change that. Let's remove our configurations. Router BGP1. Okay, no BGP default. IP version for unicast. Not unicast needed. Address family. IP version for unicast. Okay. So neighbor. So we say no neighbor. 12. Okay, the IP address and the weight 10. in, okay? If we check the routing table, it still shows there. Why? Because BGP doesn't do anything by default. We have to do the clearing again for us. Okay, clear BGP in again, and now let's check. Now it's 0. So what we do to only reach that network and make it as 10 only for that network, not for 66 as well. We have to configure access list or prefixes to classify the network and then put it inside a route map, which is we can use access list and prefix list for classification and filtering. Classification, for example, to select some ranges for NAT, for anything, and filtering, to reduce the size of routing table. But for route map, which is a powerhouse, and we can use it has more features. We can use a lot of features inside it. We can use access list and prefixes inside the route. Okay, but we cannot use route map inside the prefixes or access list. So anything, access list or prefix list doesn't matter. We configure prefix list and then what? For example, SS, okay, and then permit. Then after that, we have what? We have to select the range. Okay, we selected this one. We created that prefix and we create the route map after that. Route map word, the word I say map, okay, and then permit, okay, only with question mark. Then we have sequence number, I would say 10. We created the route map and then we put that prefix inside the route map. We say match, okay, match what? IP prefix list. So we say match. There are a lot of things. Match IP, match IP. Mm, so match interface, I think interface, or match, I think match IP. So I have to match IP address. Yes, match IP address prefixes. So we have to use question mark and find the right one, which is a lot of commands. So we cannot memorize it. We have to use our skills to find the correct one. Okay. Match IP address prefixes. What was my prefixes name, which we use it for the network quad 5? Let's find out. SS, okay, SS. And after that, we set wait, okay, inside the route. Set wait 10, okay, for quad 5. What was the route map name? Let's check it. Was map, okay. We selected the route map and we created as well. So then after that, we exit and we create another route map. Route map permit 20. Why we created another route map? Because we don't want to make any changes in other networks. We only want to change in that network for path selections. So we don't want that anything more to be changed inside the networks and the routers as well. So we have to you have to create another route map, similar name, but different, just different sequence number. It can be any number, it doesn't matter. And why we use permit? So we want to permit that actions as well. Okay, and then what we do, we use the route map inside the BGP. Okay, no BGP default IP version 4, and then address family IP version 4 unicast. Then what we use? We use neighbor. Okay, neighbor what? Okay, so any neighbor. Yeah, so we use this neighbor. Okay, Route map. What was the route map name? Map. The name was map. And then inbound or outbound, I guess. So no, it says it doesn't support. Why? Because as we said, wait support inbound. Another feature is we have like IGP or communities that supports outbound direction. So we have to use inbound. Why? Because we use it wait. Okay. So it tells you everything. Because if you use advanced iOS tools, inbound, and then okay, we use it. Uh, let's check. Yeah, after that, yeah, we use it. As if we check the routing table, it is similar. Why? Because we doesn't use BGP clearing. As we said, BGP doesn't do anything by default, so we have to use the clearing, our clearing command. Okay, we use it, and then as we say, it doesn't change. It changes nothing inside this router, inside this network. I mean, 4 6s. It only changes the wait for that remote remote IP address of that network. Okay, the remote neighbor for the router one, which is 1 2, we selected and we use it wait then for that. So it only does that for router 2. It doesn't do that for the quad 66s for both. For the quad 66 network, which is 1 2 as well, and for the quad 555 for this remote IP address as well. It only does the wait for that network. Why? Because we use it access this. We only selected we only selected. Let's find out. We only selected this network. We just wanted to reach that network from this path to be the best path. And for another network, quad 6 will be similar. That will be similar. No way changes. Okay. I hope you get that. I hope it will be obvious for all of you guys. Love you all. See you.